POV aus Berlin. My name is Matthias Rillig, and today I'd like to talk about how to maximize external validity of a study. So first of all, what is external validity? Well, external validity is in essence the degree to which your results can be generalized. And so that is a very important feature of study quality. It's important, of course, when you consume research to judge the degree to which these results can be generalized, but you can also design your own experiments or your own studies more generally so they have a greater impact. And so let's go through what this all means and what you can do. What does this mean specifically? Let's for example, assume you want to do an experiment on invasive plants, let's say. How do invasive plants, for example, change some aspect of soil biogeochemical cycling? Well, if you wanted to have an experiment that can be generalized to invasive plants, you need to replicate the status of a plant to be invasive. So you cannot do this experiment just on one invasive plant, but you have to use several species of invasive plants. And if your pattern then holds up, then you can make a more generalized statement about invasive plants do this. To give another example, for example, we've been interested in finding out what are the effects of microplastic on various soil properties, on soil biodiversity, soil processes. And so you could just take any kind of microplastic and grind it up and put it into soil and observe what happens. But then you have really not captured a lot of the diversity of plastic, because plastic comes in various polymer types with many different additives, different shapes, and so on and so forth. So there is a whole parameter space of plastic. And by having just one plastic type, you can only really say something about this one plastic type. But if you wanted to say something in more general terms about what plastic does, you really need to have covered that in your experimental design. So maybe you have different plastic shapes that you include in your experiment, such as fibers or foams or films or particles or fragments. And if whatever you examine holds up, or to some extent anyway, then you can make more generalizable statements, and more general statements have greater impact. So it's very important from the very beginning of such studies to think about how can you broaden the impact of the statement that your experiment allows you to make. There's many other examples like this. For example, you wanted to study some particular soil process. Well, you study it only in one soil. Strictly speaking, your results can only be generalized to that one soil. So your study can have higher impact if you look at a greater diversity of soils with different properties. And if you are interested in also studying, let's say, some plant or some soil interaction, it may be also interesting to look at it in different climate situations, because then your results can be generalized to a broader parameter space and therefore have higher impact. So I think the advantages of thinking about study external validity and the degree of generalizability are quite obvious. And so you could ask, why doesn't everybody always do such studies with great impact? Well, the reason this is not always possible is, of course, this comes with a cost. And the cost, of course, is enormous. The cost just means, you multiply up your experimental design. If you have 5 soil types instead of one soil type, your number of replicates is just times 5. Or the same for microplastic types, the same for climate variables, and the same for plant types, let's say. So there is a real cost to external validity. It is literally cost in terms of money, in terms of analysis cost. It's also logistics, it's time investment. So it's time and effort and real cost that sometimes prevents having high external study validity. So this is an important point because it is so costly to have more replicates, in some experiments more than others. It always means more time. It pays to really very clearly think through for which parameters you want to have maximized external validity, because you cannot do it for let's say microplastic type and soil type and plant type and climate parameter space. It simply is not possible. I mean, this is where a different type of study comes in later, like meta-analyses, or where you synthesize experiments from a wider range of experiments. But it'd be completely unreasonable to expect that of one experiment. So for your particular study that you're designing, you need to think very carefully through what is the aspect of the experiment that I would like to have a greater degree of external validity for, and then make a very targeted investment of that. And at parity of other factors, it is very clear that if you have higher study validity, your impact of the paper will be greater. So it is something that really pays off to think about from the very beginning, which of the parameters would you like to have broader representation in terms of parameter space. So as you think about this aspect, also keep in mind that, maybe for exploratory types of experiments, we are trying to find something out for the first time. It may not be worth making this investment because that study can carry itself by virtue of novelty. But when some particular circumstances or processes already been established, then it may be really worthwhile thinking more about, and now how generalizable is this finding? And that can be another major result basically to contribute to science. So this is, of course, if you yourself are designing experiments, it's important to keep in mind. But remember, this is also very important for you when you review experiments that have been published or papers that have been published. And I don't just mean in the formal sense of a reviewer, an anonymous reviewer of a manuscript that's been submitted to a journal. Also when studies appear, and when typically in the discussion section statements are made that appear to be quite a lot more general than what the data actually allow, that is also a very important point of criticism of a paper. Does the generality of the statement really match what has been done? And usually, the fact that it limits this is the external validity of the experiment as it's been carried out. Hi there. If you like this video, don't forget to click like down there. Also remember to subscribe to the channel and feel free to leave comments. See ya!